Now we're going to talk about something else related to the inverses of functions, and that's the domain and range of the inverse. So domain and range of functions and their inverses. So remember when we were talking about creating an inverse, right? When we created an inverse. I can never spell inverse right. Have you noticed that? When we created an inverse, what did we do? We switched what? We switched the x and y, right? We switched the x and the y. Can you hear my charmy clock? We switched the x and y, okay? So remember what we talked about with domain and range? Which one was all the x's and which one was all the y's? Remember the domain was all the x's and the range was all the y's. So really, one way of saying is when we created the inverse, not only did we switch the y, but we also switch the domain and range. Does that make sense? If you switch the x's and y's, you're going to switch the domain and the range. Okay? When you switch the x's and y's, you're also going to be switching the domain and the range. So this is actually pretty interesting. So say we've got something like, let's see. Whenever you see these functions, for example, the way that I keep this straight actually is using a table. So when you see these problems, you'll see f of x is equal to x squared minus 1. So we'll say, let me try this again. It'll say find the inverse for f of x is equal to x squared minus 1. And then it'll do something curious. It'll say x greater than or equal to 0. Okay? Now, usually, to be perfectly honest, we ignore this stuff, right? Because we're lazy. But this is actually important. I'm not just going to say actually important, it's actually really important. Right? Because we talked about how we can't find the inverse of a function if it doesn't pass the vertical line test, right? And then you might say, well, you know, this isn't going to pass the vertical line test or the horizontal line test, because I'm going to go in here and I'm going to graph it. I'm going to get x squared minus 1, and I'm going to graph that, and it's going to be all over the place. You say, well, that clearly doesn't pass the horizontal line test. Well, here's the deal. We have to pay attention to what we're given. And what we're given here is it says find the inverse for this, and it says x is greater than or equal to 0. So really what we're doing here, and I'm going to see if I can expand this a little bit. Really what we're doing here is we're only counting this part of the graph. We're only counting the part of the graph here. We're only counting this part of the graph. So we're actually pretending that this part of the graph doesn't exist at all. So really what we're doing is we're finding the inverse for the function that looks like this. Okay? Now that clearly passes the horizontal line test, so we can find an inverse for it. And it's kind of like magic hand waving, but the net effect is that we can take functions that don't normally have inverses, and by limiting the domain, we could actually get it to work. So I usually put together a table, and I'll say, here's my f of x, and then here's my f inverse of x, and here's my domain, and here's my range. And I know that my domain of my inverse and the domain of my function are going to be the same, and I know that the domain of my inverse and the range of my function are the same. Did I say that right? The domain of the function and the range of the inverse are the same. The range of the function and the domain of the inverse are the same. And honestly, the best way I keep this in track is to put together a table and draw my arrows. So we're given the domain right here, right, of this function. Find the inverse for f of x, where x is greater than or equal to 0. This means this is the domain, right? So that's code word for domain. This is the domain of that function. So I can say my domain of this function is x and greater than or equal to 0. Now, since I know the domain of this one is the same as the range of the other one, I can just follow my arrow, and I can write that in without even thinking about it. Because that's what it's going to do. It's not only going to ask you for the inverse, it's going to say, find the domain and range for each. Okay, so that's how I can do that there. Now, finding the range, there's two ways I can do that. I can either look at the graph and do the range. So in this case, the range would go from, I think if you look at the graph before I covered it all up, this point here was 0, -1. So I can either look at the graph and say, okay, well, my range goes from, if I smush it, my range goes from here up. So my range, you could say, on my function, goes from, for x is greater than or equal to -1, you could say it goes from -1 to infinity, and then fill it in this way. They went to work. Sorry. And -1 to infinity. Or what you can do is you can actually find the inverse of the function and find the domain of that. So we'll do that next. So what you can do is you can come over here. So this would be basically the answer, except now you actually need to find the inverse. So we have this. We're going to switch our x's and y's. We're going to solve for y. I know I'm starting to get a little bit messy. But now when we do the square root, we're not going to do the plus or minus because our chart says that we only want the positive part. We only want the greater than part. So what we do is we just drop the plus or minus and we stick with that. So this is actually our inverse function is just, the inverse function here is just the square root of x plus 1. And we don't have to worry about the plus or minus part. So usually whenever we do this, we drop the plus or minus part and we're in pretty good shape.